Greetings, folks. We're going to revisit some previous worksheets. So I'm going to go through these and I'm going to go through them very quickly because I want to make sure that I answer everything swiftly and efficiently, but I don't want to drag out the details here. So what I'm going to do with these first questions, I'm going to take the base and I'm going to raise each side to that power. So s equals z squared, 2 to the on both sides, 16 equals 2 to the fourth. Z to the on both sides, cancel 29/13 equals Z to the S. And do 1,000 to the on both sides. And so 10 equals 1,000 to the 1/3. And if I keep going like this, logically you can see that 1 over 243 is going to be equal to 3 to the -5th. 1 over 343 is going to be equal to 7 to the -3rd. And that should give you the idea of how to approach these top questions. Now, I'm gonna have to clear this so I can scroll down, so make sure you got what you need. And now we're gonna take a look at these rewriting in logarithmic forms. Now, the idea is gonna be the same here. We're gonna do something to both sides, except what we're going to do is we're going to do log base to both sides, and the base of the exponential will be the base of the logarithm. So in this first case, our exponent has a base of m, so our log will have a base of m. And log base m of m to the cancels, and we have r equals log base m of 19 over 3. All right, we're going to do log 100 of both sides. And so this cancels on the left side in 1/2, but we now have log of 100 on the right, and that's being applied to 10. And similarly, 4 is equal to log base 2 of 16. 1/5 is equal to log base 1024 of 4. -3 is equal to log base q of s, and -5 is log base 2 of 1 over 32nd. Now, I am always very vigilant to point out that it's tempting to do the, you put this here and you put that there thing. So you go, oh, well, this number comes here and this number goes there and this number goes there. And that works, but it's more important to recognize that what you're really doing is applying a process to both sides. You're saying log base 2 of 2 to the -5th is equal to log base 2 of 1 over 32. And then from the left side, the log base 2 and the 2 to the cancel. And we're just left with the -5 coming down. So that's going to be the general process for those. About to clear the screen, 3, 2, 1. Okay. So now I'm going to scroll this down and we're going to have evaluate each expression. So with these are always rigged to be done by hand. So even though normally I would tell you, oh, just type it into the calculator, because we're going to be solving these by hand, what we're actually going to do is we're going to write them in exponential form. So we're going to do exactly what we did up top, where we do 64 to the on both sides, or in this case, 8 to the on both sides, 2 to the on both sides. So we're going to rewrite this as 8 equals 64 to the x. This is going to be, we don't know what this is, so we'll say it's 2 equals 8 to the x. And so every single one of these, I'm just going to say, I don't know the answer, so I'm going to set it equal to x. That is the way that we're going to approach these. Is we're going to start off by declaring the answer to be some unknown variable. And then from there, we're going to exponentiate both sides. And so I'm just going to go through and rewrite all of those in exponential form, exactly the way we would have done those questions in the first section of this page. Absolutely nothing has changed. You're just doing the base of the logarithm to both sides. But then the next step from here is that we are going to need to use exponent properties to mess with these. So we're going to go, oh, well, 8 to the first is equal to 8 squared to the x, and we can make these out of the same base. So I start using my exponent properties. I conclude that 1 equals 2x, and therefore x is equal to a half. 2 to the fourth equals 2 to the x, so obviously x equals 4. 11 squared is equal to 11 to the x, so x equals 2. All right, this one is a fraction, so we need to remember that we're using a negative exponent here. 2 to the negative fourth is equal to 2 to the x. X is equal to negative 4. 8 squared is equal to 8 to the x, so x equals 2. 2 is equal to 2 to the third to the x. So this is 2 to the first, mind you. So 3x equals 1, x equals 1/3. Power to a power rule, we multiply the powers. All right, 1024. We'd have to do some fancy checking. Maybe you want to go to your calculator, start typing 4 times 4 times 4. It'll take you 5 of them to get there. So this is 4 to the negative fifth is equal to 4 to the x. So therefore, x is equal to negative 5. Alternatively, you could make them both out of a power of 2. That also works. Speaking of 2, this is 2 to the third to the x. So 3x equals 1, and x equals 1/3, because this is 2 to the first. All right, 3 equals 3 to the fifth to the x, right? It's 5, like 3, 9, 27, 81, 2, 4, yes, to the fifth. All right, so 3 to the first equals 5x, so 5x equals 1, x equals a fifth. And finally, 512, 8 times 8 is 64, times another 8 is 512. So this is 8 to the negative 3 equals 8 to the x. So x equals negative 3. And there is a complete rundown of the first sheet that we did in the last video. Erasing in 3, 2, 1. Okay, so now we're going to hop over to the other sheet that we looked at. Let me zoom it in a little bit here. Ooh, not that much zoom in. One too much. Back out. There we go. All right. This looks, is this the same sheet? No, this is not the same sheet. It just looks very, very similar. Okay. So we're going to take a lot of the same processes here. We're going to say in exponential form. So we're going to do z to the on both sides. S equals z to the second. 16 is equal to 2 to the fourth. 29 over 13th is equal to z to the s. 10 is equal to 1,000 to the 1/3. 1 over 243 is equal to 3 to the negative fifth. 1 over 343 is equal to 7 to the negative third. When we write these in logarithmic forms, these look suspiciously like the questions on the other page. Like, are they the answers to the questions on the other page? I think they are. All right, we're going to do, to write these in log form, we're going to need to do log base on both sides. So we're going to do log base m on both sides of this thing. Log base m of m to the r is r. And the right side, we're just going to rewrite and keep it as is, log base m of 19/3. So if we were to do this one, 1/2 ends up being log base 100 of 10. And 1/5 ends up being log base 1024 of 4. Negative 3 is log base q of s. So there's our solutions. Clearing the screen in 3, 2, 1. And we'll scroll down. These last two, it's going to be 4 equals log base 2 of 16, and negative 5 equals log base 2 of 1 over 32. Now, evaluate each expression. These look very, very similar to the questions we just had on the other sheet, because obviously they were partnered to go together. So once again, set everything equal to x, first of all. And I want to restate, this is not what I would do to solve a logarithm in general. Normally, I would just go right to a calculator and type it in. But because these are designed to be no calculator questions, this is how we're going to approach these. This is just to humor the teacher for the teacher questions here. This is not a real world practical thing. All right, and then we will write these in exponential form. So 8 equals 64 to the x. 16 equals 2 to the x. I have to sneeze. It's going to come out in a second. 121 equals 11 to the x. 1/16 is equal to 2 to the x. 64 is equal to 8 to the x. 2 is equal to 8 to the x. 1 over 1024 is equal to 4 to the x. 2 is equal to 8 to the x. Wait a minute. Wait a minute. I thought that was funny in the other sheet, but here we go. We got it all over again. All right, 3 is equal to 243 to the x, and 1 over 512 is equal to 8 to the x. Okay, so now we're going to try to put these to the same base. 8 to the first is 8 to the 2x, so 2x equals 1, x equals a half. 16 is 2 to the fourth equals 2 to the x, so x equals 4. This is 11 squared. I really feel like I'm just doing all the same questions all over again. 2 to the negative fourth is equal to 2 to the x, etc. 8 squared is equal to 8 to the x, so 2 equals x. 2 equals 2 cubed to the x, which means that 3x equals 1, x equals a third. 1024 again is still 4 to the negative fifth. So x is equal to negative 5. We already answered number 6 because it's the same as number 2. 3 equals 3 to the fifth to the x. So 3 to the first. So 1 equals 5x. And therefore x is equal to a fifth. And 8 to the negative third is equal to 8 to the x. So x is equal to negative 3. Okay. So that's the old stuff that we are re-clearing just to make sure that we are completely crystal on everything that's been going on. But we do have some new content today. So, wait a minute. Oh my God, it was a different sheet. We did just redo everything. I'm an idiot. Okay. So that explains why it felt like the same thing. I just literally did the same sheet twice. Okay. Okay. Fine. And because I'm a crappy video editor, I'm sure I'm just going to keep that all in and not care. All right. Log properties. Right. So we're going to say, rewrite this with powers. Log 5 of a to the 15th plus log 5 of b to the third. And then we're going to bring them together using the sum to multiplication property, log base 5 of a to the 15th, b to the third. Similarly, all these other ones, we can do the same idea. And I'm going to switch to a text tool because I don't feel like trying to write these all out manually. So this is log base 5. I'm not going to write the 5, but it's base 5 of a squared plus log base 5 of b to the 10th, which in turn is log of a squared times b to the 10th. This is going to be log of x to the fifth. This one doesn't have a base logarithm, so it means it's common log, plus log of y to the 20th, which comes together as log of x to the fifth times y to the 20th. I guess I should put these in parentheses just to make it clear. All right. Log base 8 of x to the fifth plus log base 8 of y to the 15th, which is log of x to the fifth times y to the 15th. Make sure that when you're doing this, you're writing base 8 on these because obviously that needs to be there. All right, log base 8 of 6 squared, or 36, minus log base 8 of 5 to the fifth. All right, now instead of an addition, this is a subtraction, so it means that we're going to have division. So 6 squared divided by 5 to the fifth, which normally you'd write as a fraction, but I'm doing a slash because I'm on a keyboard here. Okay. Log base 4 of u to the fourth minus log base 4 of v to the sixth, which is log of u to the fourth over v to the sixth. Log of x squared plus log of y to the eighth, which We will then say outside addition means inside multiply. Don't do it the other way around. If it's an inside add, you don't want to treat it as a multiply. You don't want to rip that apart in any capacity. Make sure that you're familiar with those log properties. I did go over these in the last video. So if you're unclear, take a look at that again. So not much to say here. We're just kind of going through the motions of repeating the same process with every single one of these. Log of x to the third minus log of y to the sixth, which is log of x to the third over y to the sixth. And once again, just to reiterate, we do technically need the basis on all of these. So that's a 5, that's an 8, this is an 8, this is a 4, this is a 2, this is a 2, this is a 9, and this is a 6. That gets carried throughout the question. All right, so there is our condensation of logarithms, not to be confused with the condensation of like steam or anything like that, or water or whatever. Okay, and then we're going to expand. So now we go in reverse. So we're going to say this is log 9 of, honestly, I'm going to rewrite this first of all. I'm going to say that this is log of u to the sixth over v cubed, because I think that that's going to be easier. So now this is log of u to the sixth minus log of v cubed, which then we bring the powers out front, is 6 log u minus 3 log of v. All we're doing is reversing exactly what we did before. And we're doing it in the exact opposite order. Six log A plus 3 log B. And these all retain the bases that they had. Oh, I did that one. We're not going to repeat more stuff. No more additional repetition, please. 5 log x plus 2 log y. All right, once again, I think that this one is easier to do if we rewrite it first as log this, and then we will go ahead and simplify this. This is 2 log x plus 10 log y, and log base 7 of u to the 24th divided by v to the 6th. That's just a simplification. That's no log properties. So these ones that have 3 lines, I'm just doing an extra step to make it easier for ourselves first. And because it's a divide, we turn it into a subtract, and we bring our coefficient out front. So monkey see, monkey do all the way through this whole process for the entire worksheet. All right, hopefully there are no questions on that. Clearing now. Now we'll go to the new sheet. Okay, so the new sheet is illustrating these log properties. So zooming in here, complete each rule, yes. So what this says is that we have log base b of m plus log base b of n. The quotient rule is the same thing, except instead of adding, we're going to subtract. And finally, the power rule says we bring the power out front as a coefficient, so n times log base b of m. And that's your cheat sheet that you will use for everything else. So in light of that, condense into a single log, simplify if possible. So log base 7 of 9 times 4. Because we're using the product rule here. We're saying we had this version and we're going to that version. We will sometimes go the other way and we will expand, but these instructions say condense. All right, so this is log base 2 of 80 over 5 because the subtraction leads to a division. And therefore, this is log base 2 of 16. Now, unlike the 7 and the 36, where you cannot say 7 to some power is 36. We can actually simplify this one. So I'm going to take this one step further, and I'm going to say this equals x. And then we're going to do 2 to the log base 2 of 16 is equal to 2 to the x, cancel. 16 equals 2 to the x, and we're going to then conclude that x is equal to 4. This is basically going back to that sheet that I redid, and that entire second part of the sheet is exactly what we just did here in the pink. All right, 1/2 log base 3 of 81. We can either do the log property before or after. Both will work here. I'm going to choose to do the log property first. This is log base 3 of 81 to the 1/2, which of course means square root. So the square root of 81 is 9. Now we got to do the pink again because 9 is a power of 3. So this is equal to x. We do 3 to the log base 3 of 9 is equal to 3 to the x. Cancel. 9 equals 3 to the x, and therefore x is equal to 2. All right, now we got some more interesting looking ones. Log base 4 of 8 to the 3rd minus log base 4 of 2 to the 5th is equal to log base 4 of 8 to the 3rd divided by 2 to the 5th. 8 to the 3rd, well, 8 is 2 cubed, so this is actually 2 to the 9th. So 2 to the 9th over 2 to the 5th is 2 to the 4th, which is 16. Check it on a calculator if you're not sure. And we're going to look at this, and if we rewrite this in exponential form, we get 16 equals 4 to the x. So therefore, x is equal to 2. Log base 5 of x to the 7th plus log base 5 of y to the 4th to the 3rd, which is y to the 12th. And then we can condense these using the product property and say this is x to the 7th times y to the 12th. I'll put these in parentheses for good measure. Obviously, there's no simplifying if these are variables and not numbers. And then they decide they're going to make it look icky. All right, fine. So, you know what? These parentheses are completely superfluous. We can ignore them. So log base 3 of a to the 7th times a to the 4th divided by, now this comes up here as a power, mind you, divided by b squared. Now I just did like 3 steps at once. I encourage you to take a step back and pause and think about how I got here. By bringing the power up, by doing the product rule here, by doing the quotient rule there. I used every single property in this question. So I would watch out for that. And then I'm going to just do a slight simplification of the top and call it a day. All right, so there is the complete rundown of these questions, clearing in 3, 2, 1. So let me scroll down now. How much do we have? Okay, so we'll do these next 6 now. Log base 4 of, all right, x to the 7th divided by x squared times, this comes up here as a to the 4th power, so this is effectively x to the 12th. So we're going to say times x to the 12th, and now we simplify x to the 7th times x to the 12th is x to the 19th, divided by x to the 7th is x to the 17th. All right, 1/2 log 645 minus log 6/5. All right, I'm going to simplify the stuff on the inside first. I'm going to say this is log base 6 of 45 over 5, which is 9. So let's remember that this right here is 9, and we're going to bring the 1/2 inside as a power, 9 to the 1/2 plus log base 6 of 12. All right, so this is now a 3, right? Square root of 9 is a 3, so this is log base 6 of 3 times 12, which is 36. And we can simplify that by writing it in exponential form. 36 equals 6 to the x. Therefore, x is equal to 2. Log base 9 of 35 minus log base 9 of 7. Use the change of base formula to evaluate when we're done. Ooh, fancy. Okay, so we still are condensing. That hasn't changed. Log base 9 of 35 over 7, which is log base 9 of 5. Okay, now the change of base rule looks like this. Log base b of whatever number you've got in here is the same thing as log of m over log of the base that you had, and you can make whatever new base you want. You can pick anything at all you want. So you can use common log, you can use natural log with the ln, you can do whatever you want. So I'm going to just, in order to very clearly emphasize that we're using a different base, I'm going to write it with ln, natural log. That is just a very specific logarithm. I'm going to say this is ln of 5 over ln of 9, which is something we can type into our calculator without having to dig into any menus. So ln of 5 divided by ln of 9 is 0.732. All right, so you are going to be using a calculator to solve these in the end. It's worth noting that you could have just typed the whole thing into a calculator to begin with, but we were told not to do that. That was part of the instructions. So log base 3 of 8 squared minus log base 3 of 2 to the 4th. So this is 64 and this is 16. So log base 3 of 64 divided by 16 is 4. All right, so this is equal to whatever log we want of 4 divided by whatever log we want of 3. And if you're confused about the ln thing, I'll do the next question without it. But all you need to know about ln is it's a very specific logarithm. It's logarithm base this fancy number e, which is about 2.7. Okay, so 11, we'll say log base 4 of 8 to the 1/3, which is a fancy way of saying cube root of 8, which is 2, plus log base 4 of 15. So this is log base 4 of, this is the product rule, so 30. All right, so then using change of base, we can say this is log of 30 over log of 4. And you can use, we could put a different base here, but I'm just going to use common log now. So I'm going to use the LOG button. Say log of 30 divided by log of 4. And I get 2.453. Now check it. If you had used the ln button instead, you should have gotten the exact same thing. Yes, yes, you do. Okay. So now this 2 comes up here as a squared. So this is a 9, right? So log base 2 of 27 times 4 divided by 9. 27 over 9 is 3. So this is log base 2 of 12, which is log of 12 over log of 2. This change of base rule is not really needed if you have a more advanced calculator, but not everybody is always going to be using a more advanced calculator, so that's why we have this. It's what we did before we had TI-84s. It's also what you may have to do if you're working with a scientific calculator. So you do want to know how to do this. Also, the change of base rule does make certain questions a lot more simple to handle that you may see later on. Okay, so there's a rundown of 7 to 12. We got 6 more to go. So I'm going to clear the screen. And we're going to scroll. Expand each expression. Okay, so now we're just taking our log properties and going in reverse. So these should be fairly easy. We're going to say log base 8 of m plus log base 8 of n squared. And then we'll use our power rule to bring that down. And so that becomes 2 log 8 of n. and the other one stays the same. 14, it's a division, so we're going to write it as log, just common log. They didn't put a base, minus log of y to the fourth. And then we're going to bring our powers outside. So 9 log x minus 4 log y. And yes, there are times when you do need to do this and go in the other direction. Just like sometimes you factor and sometimes you multiply out when you're doing algebra stuff. All right. I'm going to simplify this first by cubing the guts of this thing and say it's a to the 15th, b to the 6th, because why would we do it any other way? It's just more work if we don't. And if we take this apart as a plus log and then we bring our powers down, we're going to end up with 15 log base 2 of a plus 6 log base 2 of b. All right, this is the same thing as log of p to the 8th over q to the 14th. So this is going to be a subtraction between these. And then when we bring the powers out front, we have 8 log p minus 14 log q. And do these last two questions in 2 steps if you need to. Don't feel like you have to do it all in one. I'm just cutting to the chase a little bit here because this video is getting on the long side, especially after I went and redid an entire worksheet because I'm an idiot like that. All right, so I'm going to apply the 1/2 power to everything because that's what square root is. So this is 7/2 log base 5 of a plus 1/2 log base 5 of b. And finally, log base 4 of, I'll do this one in all the steps just to make sure that we are understanding what's going on. So to the 1/3 power is going to be power to a power rule. So this is log 4 of c to the 2/3 plus log 4 of d to the 5th, and then we'll bring our powers out front. 2/3 log base 4 of c plus 5 log base 4 of d. All right, there is the complete rundown. There's a whole bunch of fun stuff with worksheets. So hope you enjoyed that and that this creates a greater understanding of what you need to do with this content. But we're going to call it a day here. So have a good one.